Hi everyone. In this video I will talk about trigonometric identities. In next few examples we're going to learn different techniques to verify trigonometric identities. For example, if this is one of the identity question, if they ask us to prove these two are to verify the identities, at the beginning we need to make a decision on which side should we start. Should we start from the left hand side to go to right hand side, or right hand side to go to left hand side? That's the first thing we should make a decision on. The second one, in order to prove the identity, we need to have some tools. The main tools are, besides algebra, just adding or subtracting, we need to have some fundamental identities. Those identities are the basic one that we already know, like tangent of alpha equal to sine of alpha over cosine of alpha. Cotangent of alpha is cosine of alpha over sine of alpha, and secant is 1 over cosine, and cosecant of alpha is 1 over sine of alpha. Also, sometimes we use the first identity, which is cosine square of alpha plus sine square of alpha equal to 1. So by knowing those fundamental identities, by knowing algebra, adding, subtracting, finding common denominator, also making a decision which side we start, we should be able to verify identity questions. So now you're going to see a few examples in whiteboard. All right, my first question is tangent of x multiplied by cosecant of x equal to secant of x. So they're asking us to verify each identity. So we learned that the first step, we have to decide should we go from left to right or from right to left. Definitely, if we start from left hand side, we have something to simplify to get to the other side. The second step is we know some fundamental identity. We know that tangent of alpha equal to sine alpha over cosine alpha. Cotangent of alpha is cosine alpha over sine alpha. Cosecant of alpha equal to 1 over sine alpha, and secant of alpha equal to 1 over cosine of alpha, and sine square alpha plus cosine square alpha equal to 1. So we have these tools. So let's start. So tangent of x multiplied by cosecant of x, we need to get secant of x. I'm going to make a line here. I'm going to write that I'm going to start from the left hand side. Instead of tangent of x, I will write sine of x over cosine of x. And instead of cosecant of x, I will write 1 over sine of x equal to sine of x, they cancel. We will get 1 over cosine of x, and 1 over cosine of x is secant of x. Therefore, we proved it. Let's have another example. Secant square of theta minus 1 divided by secant square of theta equal to sine square of theta. Right, so first step, we need to make a decision on from left to right or right to left. It would be a good idea if you pause the video and try to simplify this or verify it, and then let me solve it. I mean, just pause it, you do it, and then unpause the video to see if we are proving the same way. I will start from the left hand side because there are more things to do. The right hand side only we have sine square. So if we start from here, there are so many ways to get to other side. I will like to break it down like this. I would like to say secant square of theta over secant square of theta minus 1 over secant square of theta. So how did I get this? Little note for you guys. If we have a plus b divided by c, I can write this a over c plus b over c. So if it's a minus, you also can make a minus. So I break it down like this. Secant square of theta over secant square of theta, they cancel. The answer is 1. 1 minus 1 over secant square of theta. We know secant of theta equal to 1 over cosine of theta. If you square it, you can square here. So secant square will be 1 over cosine square. Then reciprocal of this, so 1 over secant square of theta will be 1 over cosine square theta, which the answer is cosine square theta. So 1 over secant square of theta will be cosine square of theta. So we got 1 minus cosine square theta. We also know that sine square theta plus cosine square theta equal to 1. This is first identity. If you solve for sine square, if you move cosine square to the other side, we're going to have sine square theta equal to 1 minus cosine square theta. So 1 minus cosine square theta, it will be sine square theta. So we proved it. Might be other way to solve this, but that's what I picked. Let's have another example. One over tangent of x plus 1 over cotangent of x equal to tangent of x plus cotangent of x. So we're going to prove the identity. We have to decide from left to right or right to left. So again, it would be great if you pause this video and then you solve it, and then watch the video to see if I proved it the same way you proved it. So here we have 1 over tangent, 1 over cotangent. What we know tangent of x equal to sine of x over cosine of x, and we know cotangent of x equal to cosine of x over sine of x. Basically, tangent of x equal to reciprocal of cotangent, or cotangent of x equal to 1 over, or cotangent of x equal to 1 over tangent of x. So we already proved it. 1 over cotangent of x equal to tangent of x, 1 over tangent of x equal to cotangent of x. So instead of 1 over tangent of x, I can just put cotangent of x plus 1 over cotangent of x, I can put tangent of x. What we have exactly the other side. Usually the identity question at the beginning looks complicated and impossible to get the other side, but as long as we don't do any algebraic mistake and follow all the fundamental identity, we should be able to verify. Let's have another question. This is a little spicy, but let's see. We have 1 plus cosine of x over sine of x equal to sine of x over 1 minus cosine of x. So this question, which side should we start? Left to right or right to left? As you see, we have only sine and cosine. In previous example, we dealt with tangents or cotangents or secants and cosecants. If we have this type of functions, in identity question, we usually make them in terms of sine and cosine. But in this example, we only have sine and cosine. So what we do, we can start from left to right or right to left, doesn't matter. I will start with left. So 1 plus cosine of x. So I'm going to start with the left hand side. 1 plus cosine of x over sine of x. So one of the technique here is we multiply by conjugate. We multiply both sides, top and bottom, by 1 minus cosine of x, 1 minus cosine of x. 1 minus cosine of x is conjugate of 1 plus cosine of x. Conjugate is, just reviewing algebra, we have a minus b and a plus b. A minus b and a plus b, they are conjugate each other. When you multiply, you get a squared minus b squared. So I multiplied by conjugate of a plus 1 plus cosine of x. When we multiply 1 plus cosine of x times 1 minus cosine of x, we will get 1 minus cosine square of x divided by sine of x times 1 minus cosine of x. So we have 1 minus cosine of x and cosine square of x at top. From the first identity, fundamental identity, which is sine square of x plus cosine square of x equal to 1. From here we have two other formula, which cosine square of x equal to 1 minus sine square of x, and sine square of x equal to 1 minus cosine square of x. So instead of 1 minus cosine of x, which is right here, I can put sine square. We're going to have sine square of x over sine of x over 1 minus cosine of x. Sine of x and sine square, one of them on top will cancel. We will get sine of x divided by 1 minus cosine of x. So this is exactly the right hand side. So we prove this. So one more time, identity question at the beginning looks strange, but they're not that complicated. Let's have one more, and that's it for today. We have cosine of x plus sine of x tangent of x. The answer should be secant of x. Again, it would be good that you guys pause the video and you verify and then activate. I go from left. Why left? Because we have something to start with. You also can start from the right, but it will be super challenging that from secant of x you come up with that much. So let's go with the green. Cosine of x, we love it. We're going to keep it as cosine, plus sine of x. We cannot do anything with sine and cosine, so we love this as well. But tangent of x, we can write it in form of sine x over cosine of x. All right, so equal to, we get cosine of x plus, this is 1, sine of x times sine of x is sine square of x divided by cosine of x. Here we need to find a common denominator, because what we got is not near the other side. So that means we need to do more algebra. The common denominator between 1 and cosine of x is cosine of x. So here I'm going to multiply by cosine x. Cosine x, we get cosine square of x plus sine square of x equal to, now I'm going to write it in one fraction, get cosine square of x plus sine square of x divided by cosine of x. This is our favorite identity, which is 1 divided by cosine of x, and 1 over cosine of x is secant of x. So we proved this as well.